Okay, Algebra 2, we need to start somewhere. And here's the challenge. Because of the human malware that is COVID, we have students that either from algebra 2 years ago, or algebra last year, or geometry last year, we have some missing pieces and we have some holes. So one of the things that we're going to need to do is we're going to need to start this Algebra 2 class in a little different spot than we've started other Algebra 2 classes. But that's okay, because here's the reality. What we're going to do is we're going to go back and we're going to get a little bit of that Algebra 1 that you may have missed, or maybe is just a little weak, or maybe is something you haven't seen in a year. And we're going to build on that moving forward. The other thing to remember is Algebra 2 isn't really a thing, okay? There's no such thing as algebra and algebra the sequel. That makes no sense. It's all algebra. And the fact that we've already talked about how algebra and geometry are really just two different ways to describe exactly the same relationships. Whether it is describing a segment using an equation, or taking an equation and creating a line or a segment, those two things are opposite perspectives on the exact same relationships. So one thing we have to understand is we got to go back far enough to realize that everything you did in Algebra 1 is a prerequisite for what we're doing in Algebra 2, because Algebra 2 is not different, it's just a continuation of that discussion. With that in mind, we're going to start pretty basic with the algebra. We're going to start with functions. Now, what are functions? Well, functions can be defined as an equation. F of x equals 2x plus 3. That same function can be graphically displayed as a set of data where you have an x and a y, and for every x, -2, -1, 0, 1, 2, you can plug in and get the answers from, I believe it was 3x plus 2. You just simply plug them into the equation and you can work it out. Alternatively, you can talk about it graphically. You can take this equation and you can say, where's the y-intercept and where's the slope? Those two concepts we'll get into, and you can create a line out of that equation. Alternatively, you can go over to the table and take the individual points and plot the individual points and connect those dots to make a line. Wait a minute, dots put together that make a line? That's right. You're talking Euclid's first postulate right there. His second postulate says if I take the points that I do know and I extend them infinitely in each direction, it will still continue infinitely in each direction. So as we begin to build this, I want you to understand that this class does not happen in a vacuum. It is built on all the stuff that was before it, and everything that comes after it builds together. So when we look at things, we can look at them as equations, we can look at them as numerical charts or tables, we can also look at them graphically and pictorially, because sometimes a picture is easier to understand than a data table or an equation. In either case, we need to start with rates of change, average rates of change, functions, relations, all of that stuff before we can even think about polynomials, logarithms, exponential functions, higher order functions, polynomials, and the like. So with that, that's what we're here to do this year. All right, let's get going.